All right, so let's go ahead and review for our quiz on graphing linear inequalities. So number 1 says y is greater than or equal to 2x minus 4. And this linear inequality is already in slope-intercept form. Our y-intercept is negative 4, and our slope is positive 2. So I'm going to begin with my y-intercept. I'm going to place a point on negative 4. And then I'm going to move the way my slope tells me to move. A positive 2 comes from the fraction 2 over 1. That means move up 2 and right 1. So I'm going to move up 2, right 1, place a new point, up 2, right 1, and I like to keep going for as far as I can. So up 2, right 1, up 2, right 1, up 2, right 1. And since this is an or equal to, we're going to graph with a solid line. Now that's only the boundary line. We now need to determine which side of this line to shade. The general rule is greater than shade above, less than shade below. So above this line would be this zone right here to the left would be above this line. But if you're not sure, what we can do is we could pick a point and substitute it into the inequality and see what we get. So very easy point to pick would be the point 0, 0, which is to the left of this line. And we're going to substitute that for x and y and see if we get a true statement. So 0, 0, our x value and our y value are both 0. So 0 is greater than or less or equal to, and we're actually asking that, right? So we put the question mark. 2 times 0 minus 4. 2 times 0 is 0. 0 minus 4 is negative 4. So we get the statement 0 is greater than or equal to negative 4. Is that true? Yes. So since origin 0, 0 is a true statement and it's to the left of the line, that means that this zone to the left of the line is the zone that we are to shade. We're just going to go ahead and shade that in red. All right, next question, number 2. Y is greater than negative 9 fifths x minus 4. So once again, our y-intercept is negative 4. And this time our slope is negative 9 fifths. So we're going to begin with our y-intercept. I'm going to place a point on negative 4. And then we're going to move the way our slope tells us to move. The slope of negative 9 fifths says move down 9 and right 5. Now if you look at this graph, I don't really have room to move down 9 and right 5 because I don't have enough room on this grid here. So what do we do when we run out of room? Well, we work backwards. How do you work backwards is we do the exact opposite of what the slope is telling us to do. So the exact opposite of down 9, right 5 is going to be up 9, left 5. So let's do that. So starting from our y-intercept, up 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, and left 5, 1, 2, 3, 4, 5. And we place our point. Now remember, the reason why this works is because if I move from this point down to my y-intercept, I am moving down 9 and right 5. So we still did move the way the slope told us to move. Now, this is a greater than, but there's no or equal to, so this line has to be a dashed line. I'm going to try my best to do this correctly, as straight as possible. This program that I'm using does not have a dashed line tool, so it's not easy for me to make it perfectly straight. But you get the idea. On your quiz, you'll have a straight edge. You'll do a better job than I did here. So next we need to figure out which side of this to graph. So greater than, again, means above, and in this case, above would be to the right side of this line. But let's go ahead and pick a point and plug it in and see if it works. Once again, to the right side of this line, we have the point 0, 0, which is a very easy point to test here. So let's test it and see what happens. So we're going to again substitute 0 for x and for y. and see if we get a true statement. So negative 9/5 times 0 is 0. 0 minus 4 is negative 4. And we get the statement 0 is greater than negative 4, which is a true statement. So since origin gave us a true statement, and it's to the right side of the line, then we know that the right side of the line is the side that we need to shade. All right, question number 3. Y is less than 1/3 x minus 2. Our y-intercept is negative 2, and our slope is positive 1/3. So we begin with our y-intercept. We place a point on negative 2, and then we move the way the slope tells us to move. A slope of positive 1/3 means move up 1 and right 3. So up 1, right 3, that's right here. And I have room to do that once more. So up 1, right 3. And again, this is not an or equal to, so this is going to be a dashed line. And again, since I don't have a dashed line tool, I'm doing my best to make this as straight as possible. So now it says y is less than 1/3 x minus 2. So we would have to shade under, and under is this zone right here. And some of these, it's easier to tell what's under and what's over, right? But once again, let's go ahead and test just to make sure. And since we've been using 0, 0, let's go ahead and keep that going. And let's see what happens. So I'm going to use the point 0, 0 to test and see if I get a true statement. So is 0 less than 1/3 times 0 minus 2? 1/3 times 0 is 0, and 0 minus 2 is negative 2. So we get the statement 0 is less than negative 2. Well, this is not true. This is false. 0 is greater than negative 2. So what does that tell me? Well, origin 0, 0 is above the line. It's in this zone, and it gave us a false statement. That means this side is not the solution. The other side is. So we're going to shade down here. And I hope you think my shading is beautiful. But you get the idea. All right, on to number 4. Y is greater than or equal to negative x minus 2. So our y-intercept, again, is negative 2. And our slope, well, what's invisible in between this negative and this x is a negative 1. So let's begin. We put our y-intercept at negative 2. And so a slope of negative 1 comes from the fraction negative 1 over 1, which means down 1, right 1. So down 1, right 1, that's right there. Down 1, right 1, down 1, right 1, down 1, right 1. You can see the pattern. And since it's an or equal to, we're going to use a solid line. So there's our boundary line right there. And we need to go ahead and shade. So it's greater than, so we would shade above, which in this case is to the right side of the line. But let's go ahead and test it out just to be sure. All right. So what if we use a point that's not 0, 0? Let's do something crazy and see what happens. Let's use 2, 2, just to do something different, right? Let's use 2, 2. So y is greater than or equal to negative x minus 2, and we're going to use the point 2, 2. So 2, is it greater than or equal to negative 2 minus 2? Negative 2 minus 2, that's negative 4. So we get the statement 2 is greater than or equal to negative 4, and that is a true statement. So this is the correct side to shade. Now the remaining examples are a little more complicated because they are not already in slope-intercept form, so we're going to need to convert them. So in order to put this in slope-intercept form, I first need to get this 7x and move it to the other side. So I want to take this 7x and I want to drop it right here in between the greater than and the 6. And remember, whenever you move something from one side of an equation or inequality to the other side, you have to change the sign. But nothing else changes signs. So this is going to become negative 2y is greater than positive 7x is going to become negative 7x, and this is still a positive 6. Let me go ahead and copy this down over here where we have room to work. So next, we need to divide everything by negative 2 in order to get y alone. So negative 2y divided by negative 2, that's y. Negative 7 over 2x divided by negative 2 is going to become positive 7 over 2x. And positive 6 divided by negative 2 becomes negative 3. But something else happens here. Because of the fact that we had to divide by a negative 2, this greater than has to switch to become a less than. And so now this is in slope-intercept form, and now we can graph. So our y-intercept is negative 3, and our slope is 7 over 2. So we place our y-intercept on negative 3, and we move the way our slope tells us, which is up 7 and right 2. So 1, 2, 3, 4, 5, 6, 7, 1, 2. And here is our new point. And this has no or equal to, so we're going to have to, again, I'm going to have to freehand this dotted line because I do not have a dashed line tool on this program. That came out bad, but you get the idea. And next we have to graph. This is less than, so we need to pick a point, or we need to shade the zone that is under the line, which in this case is to the right. But let's go ahead and test it and pick a point. So I'm going to pick the point, not 0, 0 this time. Let's pick the point 2, 0 and see what we get. Okay, so we're going to pick this point right here, 2, 0. So I have here y is less than 7 over 2x minus 3. And we're going to take this point and plug it in. 2, 0, so 0 is less than 7 over 2 times 2 minus 3. 7 over 2 times 2 over 1, these cancel out. This gives me 7 minus 3, which is 4. So we get the statement 0 is less than 4, and that is true. So now we know that this is the correct side, and so we shade it. Isn't my shading amazing? I hope you think so. All right, now on to number 6. Again, I need to put this in slope-intercept form. So again, I need to move this 7x here. And I need to place it right here in between the greater than or equal to and the negative 9. And when I move it, it's going to become a negative 7x. So this will look like this. 3y, it's going to stay a positive 3y, is greater than or equal to negative 7x minus 9. Once again, the only thing that changes signs is the term that you moved. That's the only term that changes signs. So let's bring this over here so we have room to work. And next thing I need to do is I need to divide by 3 in order to get y alone. So I get y. Here I'm dividing by a positive 3, so this sign is not going to change. So y is greater than or equal to, and negative 7x over 3 just becomes negative 7/3 x. And negative 3 divided by positive 3 is negative 3. So my y-intercept is negative 3, and my slope is negative 7/3. Place my y-intercept at negative 3, and then my slope of negative 7/3 tells me to move down 7 and right 3. However, I don't have room for that. So I'm going to have to work backwards. So what is the exact opposite of down 7, right 3? that's going to be up 7, left 3. So here we go. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. And there's my new point. Once again, the reason why this works is if I move from this pink point down to my y-intercept, I am moving down 7 and right 3. And now we need to graph. Since this is an or equal to, we can use a solid line and extend all the way. And it's greater than, so we should shade above. But once again, let's go ahead and test this out. So y is greater than or equal to -7/3 x minus 3. Let's pick a point. This time, let's go back to the good old 0, 0. So -7/3 times 0 is 0. And 0 minus 3 is -3. So 0 is greater than or equal to -3, and that is a true statement. So origin 0, 0 is to the right of the line, and that's true. So that means the right of the line is the correct side to shade. All right, our last two examples. Number 7, 2x plus y is less than or equal to 2. Once again, we need to move our x term to the other side. So when I take 2x and I move it right here, it's going to become a -2x. So this gives me y is less than or equal to -2x plus 2. And this is already in slope-intercept form. Our y-intercept is +2, and our slope is -2, which comes from the fraction (-2/1). So let's go ahead and work. Our y-intercept is 2, so we go to 2 on the y-axis and we put a point. And our slope is (-2/1), which means move down 2 and right 1. So down 2, right 1, there's our point. Down 2, right 1, down 2, right 1, and I could do it one more time. And this is an or equal to, so we can use a solid line. Next, we need to determine where to shade. It is less than or equal to, so we would shade under, which in this case is to the left. So let's test this out. We have y is less than or equal to (-2x plus 2). This time, let's be adventurous. Let's pick a point like -4, -4, and see what happens. All right, so -4, all right, so -2 times -4, that's +8, and 8 plus 2 is 10. So we get the statement -4 is less than or equal to 10, and that is a true statement. So we know that the left side of this line is the area that we should shade with my beautiful shading. All right, last problem, number 8. 5x minus y is less than 1. We need to take this 5x and move it right here, making it a -5x. And so when we do this, we cannot forget this negative in front of the y. It stays. So this becomes -y is less than -5x, and this is a +1, so +1. So let's move it over here because we still have some work to do. Now remember, we don't want this negative to stay here. It's y equals mx plus b, not -y. So we need to get rid of this negative. So we need to remember what's invisible in between this negative and this y is a 1. So the way we get rid of this negative is by dividing everything by -1. So what happens here? We get y. Over here, -5x divided by -1, that's going to be +5x. And +1 divided by -1, that becomes -1. And again here, since we had to divide by a negative number, this less than becomes a greater than. So let's go ahead and plot our graph. Our y-intercept is -1 and our slope is +5. So we place our y-intercept at -1 on the y-axis, and then we're going to move the way our slope of 5/1 tells us, which is up 5, right 1. So 1, 2, 3, 4, 5, right 1. There's our point, and this is not an or equal to, so we need to do our dotted line. And I've already explained why my dotted lines are so bad. So last thing, we need to shade. So it is y is greater than 5x minus 1. We would need to shade above, which in this case would be to the left of the line. Once again, if you're not sure, pick a point. It's kind of close to 0, 0, so I wouldn't pick that. So how about a -1, +1? Right here. So -1, +1. Let's plug that in and see what we get. So y is greater than 5x minus 1. And so -1, +1. So my y value is 1. And my x value is -1. 5 times -1 is -5. And -5 minus 1 is -6. So we get the statement 1 is greater than -6, and that is true. So I know that the side I need to shade is the left side. All right, I hope that this review has helped you to prepare for your quiz on graphing linear inequalities. Good luck.